Achha, so this one is March 22 question paper 1-2. Okay, we're going to start with this one. So the first part, okay, let's start. So now the first part is the first ionization energy of potassium is 418. And that of strontium is 548, which is potassium and strontium. We need a data booklet to see where they're located in the data booklet. Just 1 second. I think they're right next to each other. One is in group 1, the other one is in group 2. So where's the? This is the periodic table. So you've got no, they're not even together. There's potassium and strontium is below it. So strontium is below it. So they're not even together. Now the question is, so we know where the positions are. So which statement explains why SR has a greater first ionization energy than K? Let me have a look at it again. SR and K. Now, first thing is, should SR have a greater ionization energy or not? Should it have? I mean, my assumption is by just looking at them,
compared to K.
Compared to K, huh? Should it have a greater ionization energy or lesser ionization energy?
I think lesser, क्योंकि down the group ionization energy decrease होती है.
Okay, so down the group the ionization energy it decreases, right? So we've got a problem here because and why does it decrease? Because you've got a bigger shell, bigger atom. The electron is further away. Plus, it's going to be more shielded as well. There's going to be extra shells. So it would be easier to remove electrons. There would be too many shells in the way. The nucleus will not be attracting the outer electrons that strongly. But the problem is he's saying that SR has a greater first ionization energy than K. So that means, I mean, all our assumptions and all our factors, TK, everything is wrong. I mean, it appears to be wrong in this case. So what could be the best explanation for this? The charge on SR nucleus is greater than the charge on a K nucleus. Okay, so we're going to support factors that would help to explain why SR has a greater ionization energy. So this one over here, it does make a bit of a sense that SR's nucleus, it has more protons. So maybe because of more protons, there's more attraction. And SR nucleus, it actually does have more protons. Okay? It's got 38 protons while potassium has 19 protons. So I'm just going to go with the factors that actually help to explain this. Is this part clear, the first one?
Yes, sir.
Yes, sir.
Because all the other factors are not actually explaining that. Because it is an anomaly. It's not what we learned. It's something that goes against what we have learned. So the only hope we have is to go for the factors that help to explain you why this is happening. So over here, if SR has had greater shielding, then it would have a lower ionization energy, not a higher ionization energy. So this factor does not actually help to explain what's given above. The outer electron of SR, if it experiences more spin per repulsion, it would be easier for it to remove electrons. But over here, it shows that it's more difficult to remove electrons. The outer electron in an SR atom is further from the nucleus. That would also mean that it would be easier to remove electrons. But over here, the value shows that it's harder to remove electrons. So only the first factor actually supports the first statement. So what is the electronic configuration of Mg2+? That's usually it had 12 electrons. 2+ means that it's got 10 electrons. So that's 1s2, 2s2, 2p6, and that's it. The 3s2 is gone. So it's going to be option A. As the next one, I've got compound X and it contains element CH in O. So it's 2 grams of X produces 4 grams of carbon dioxide, 1.63 grams of water when completely combusted. What is the empirical formula of X? So I don't know what this thing is. But I know when it burns, it produces carbon dioxide and it produces water, right? So it's going to produce X carbon dioxides and it's going to produce Y/2 water molecules, right? So if I burn this, 2 grams of this, so what are the moles of carbon dioxide? What's 4 divided by 44? That's the MR. Kitne moles aate hain?
0.090.
So we're going to get 0.090 moles. Exactly 0.090. Is there anything after that?
0.09090909.
Acha. So 091, let's make it 0.091, right? So what about water? How many moles do you have? 1.63 grams of water divided by 18. That's also going to be, I think, the same number.
Yes, 0.090555.
So let's make it 0.091 moles as well. So what information that we got from here is that they have the same ratio, right? It's 1:1. So that means and remember, it's the ratio. We don't know the actual moles. We don't know what the equation is. We don't have a ballast equation. But I know that the mole ratio is going to come out to be exactly the same. Whatever the number X is, the number Y/2 is going to be exactly the same. Whether it's 2:2 or 3:3, it's going to be exactly the same number. So that means if X is equal to 1, that means Y/2 is equal to 1 as well. And that would mean that Y is equal to 2. So this indicates that X and Y over here have a 1:2, which means that if this is 1, then Y will be 2. If that is 2, the Y will be 4, right? So that means you've got two options. It's either C2H4 or it's either CH2O2, right? Is this clear?
Yes, sir.
Yes, sir.
So we figured out it's going to be 1:2. Now the next part is difficult. So which one is it, C or D? So how would you figure that out? The way you can actually figure that out is, how can you figure that out, by the way? The way you can figure this out is, can anyone any idea of how would you figure this out?
Sir, because like I don't think CH2O2 would work, no?
Why would it not work?
Oh no, it can't form, yeah.
I mean, the only thing we figured out is that carbon and hydrogen will have a ratio of 1:2. So it could be C, it could be D, right? I said, so you would have to figure out this oxygen over here. I mean, that was D, that was unknown as well. So the only possible way is you can figure out how much oxygen do you have. So we know that we've got 0.091 moles of carbon, right? So what mass do we get? Like all the carbon over here is coming from this molecule over here. So we can actually go and calculate the empirical formula. We would have to do a bit more working over here. So how much carbon do we have? What's the mass of carbon? Moles multiplied by MR. So what do you get?
1.092.
So you're getting 1.09.
Lekin sir,
Huh.
a combustion analysis ka we did an equation where and CXHY plus X plus Y over 4. Why can't we use that?
अच्छा उसके अंदर problem ये है कि X plus Y by 4 times O2 and then you have X CO2 and Y H2O, right? Y by 2 H2O. अच्छा problem is कि the formula actually has an oxygen as well. So that kind of messes this up. Because the carbons will be balanced the same way. The hydrogens will be balanced the same way. The oxygen over here will not be balanced the same way. Is that clear?
What made you know that X and Y has an oxygen with it? Because it said
CH and O only, right? So there's an O as well. Is that clear?
Okay.
So the problem is that it's I mean the main problem is that this method will probably not work over here. What you would have to do is you would have to individually figure out what the formula is. What you would have to do is that you know that it's CXHYO, right? I mean, so this is how you're going to do this. Forget combustion analysis. You've got CXHY and OZ, right? He told us that it produces a certain amount of carbon dioxide. Now, all the carbon in the carbon dioxide is coming from this, right? And the carbon dioxide produced was how much? 0.091 moles. So I'm just going to multiply it by 12 to figure out the mass of carbon, which I got. How much did we get? That was 1.092 grams, right? So that means the carbon that we have is 1.092 grams. Then similarly, we've had the water. Now all the hydrogen in water is coming from the molecule, right? So how much water did we had? How many moles? We had 0.091 moles. So I can figure out the mass of hydrogen. Like in one molecule, how much hydrogen do I have? I've got 2 of hydrogens, right? So I'm going to multiply it by the atomic mass of hydrogen only. So
0.182.
So it's going to be hydrogen, that's 0.182.
2.
And then he told us that the whole thing has a mass of, I think, 4 grams. He did mention this, that the whole thing had a mass of 2 grams, not 4 grams. So यहाँ पे did, yep, 4 divided by 44. I said the whole thing had a mass of 2 grams. Now we can figure out the mass of oxygen, subtract the mass of carbon and the mass of hydrogen from it.
0.726.
So you're getting
0.726
grams. I said now it's like an empirical formula question. It's you know the masses of each one of them. Okay, so it's kind of an empirical formula question. C, H, and O. This is 1.092 grams. If you divide by 12, you already know that's going to be 0.091 moles. फिर इसकी कितनी mass आई थी? That was 0.182. If you divide by the AR of hydrogen, that's 1. So that gives you how many moles? That gives you 0.091 divided. I mean, it will give you the same thing. And then you have oxygen. Oxygen has a mass of 0.726. Divide that by 16. What do you get?
0.045.
You get 0.045, right? I should divide everything by the smallest, which is 0.091, 0.091, and 0.091. So I think this will come out to be, what is this coming out to be?
So which one is the smallest? Is it 0.045?
Honey, it's actually 0.045. That's the smallest. You divide everything by 0.045. So you're going to get, I think, 2, 4, and 1, right?
Yes, sir. 2, 4, 1.
So that's going to be C. Okay, so this one was like very time consuming. I don't think there's any shortcut to it. What you had to do was you had to figure out that the carbon is making all the carbon dioxide. The hydrogen is turning into water. And you would figure out the mass of hydrogen and the mass of carbon from the carbon dioxide, which was, I think, 4 grams. So you were able to figure out the moles. And you were able to figure out the mass of carbon in this. You were able to figure out the moles of water, and every molecule has 2 hydrogens, so you doubled it. The AR of hydrogen is 1, so that would be it. And the remaining mass is oxygen. Then you just did an empirical formula question. TK, is this clear?
Yes, sir.
Yes, sir.
I said next one. You've got dimerization of AlCl3. Which one is the correct diagram for this? Is it covalent or ionic?
C.
B.
B. It is
Yes,
actually B. Because what happens is that Al is the one that has, and its outer shell is not complete. So Cl is the one that lends lone pairs to it. So these 2 electrons are coming from Cl. So that's one of the dative bonds over here, the one that's I'm going to highlight in red. And you've got a dative bond over here as well. So it's basically 2 AlCl3s. Al's outer shell is not complete. So there's another AlCl3. And its outer shell is also not complete. So the Cl lends a lone pair to Al, forms a dative bond. The Cl over here lends a lone pair and forms a dative bond as well. I said next one, you've got hydrogen halides, and I think boiling points are given, right? So the boiling points are increasing down the group. Why do boiling points increase down the group for hydrogen halides? What intermolecular force do they have?
Sure, they have van der Waals forces, no?
They do have van der Waals forces. What is the other force that they have? Every molecule has van der Waals
Yeah,
forces.
permanent dipole forces.
So they have permanent dipoles as well. So plus they have permanent dipole attraction. Now the question is, down the group, the molecule size increases. So which force is actually increasing?
Van der Waals only, because like permanent dipole should decrease, I think.
They should decrease because the electronegativity decreases actually. The permanent dipoles are actually decreasing. They decrease down the group because the atoms are becoming less electronegative. But because the molecules are becoming bigger, you get more van der Waals forces. So it's more van der Waals forces. That is why the boiling points are increasing. So which is the correct option? They don't have hydrogen bonds.
But I believe it's B.
It's going to be the most generic statement. That's B. That's the next one. You've got an electronegativity table. So when you have ionic compounds, large difference in electronegativity or small difference in electronegativity?
Sure, large difference, I think, no?
Large difference, right? Large difference in En values, right? Electronegativity values, Pauling scale values. That should be greater than 1.7 or a lot greater than 1.7. So the molecule is the compound is probably going to be ionic, and for ionic compounds you have high melting. It's a crystalline structure. It's a bunch of positive and negative ions all attracted to each other. So that is what an ionic compound is. So which one do you think is, and it's going to have a very high melting point. So which one do you think is ionic? It's going to have the highest melting point. So Z square, X, YZ, XZ, YZ. Who's got the greatest difference in electronegativity values?
XZ, sir. XZ.
It's going to be
XC. Yeah.
So it's going to be, so that's your answer. That's the only option you're left with is C. Z square is going to have the least electronegativity difference. So the smaller the electronegativity difference, they'll go into sharing electrons because no one would be able to pull electrons towards themselves. They would start sharing electrons. So Z square will have electrons firmly in the middle. Why? Because they will have exactly the same electronegativity value, which is why the dipole will cancel out.
Sir?
Yeah.
Sir, the range for the electronegativity, in order for a molecule to be covalent, it has to be below 0.4, right?
It has to be below 1.7.
For like non-polar covalent.
Or non-polar covalent. Non-polar covalent is something that's just very small. Like either, I mean, for example, here the difference is 0, right? I mean, in Z square, it's going to be exactly 0. There's no difference, right? But anything that's the least.
Okay.
I mean, usually it's going to be a comparison question. So, I mean, there's nothing called polar. There's nothing called non-polar. It's always a relative comparison, right? Is that clear?
Okay. Yes, sir.
So if you compare two things, the one that has the lesser difference, that's the one that's going to be non-polar. Next one. The equation is given, the enthalpies of combustion are given. So if you're given the enthalpy change of combustion of the reactants and the enthalpy change of combustion of the products, what is the enthalpy change of combustion of carbon dioxide, by the way? Like this is given. This is given. I think this is A. This one is B. What is enthalpy of combustion of carbon dioxide?
A minus 2B.
carbon dioxide ki enthalpy of combustion, that's 0. Remember, anything that's burnt already, it will not burn again. Its enthalpy of combustion will be 0. So anyways, this one is 0. So if you know the enthalpies of combustion of reactants and products, what's the formula?
Products minus reactants.
The reactant minus products. It's enthalpy of combustion of reactants.
Hi. Okay.
Minus enthalpy of combustion of products. The other one is for product minus reactants is for enthalpy of formation. So reactant in this case is A, and the product in this case is 2B. So it's going to be D. Is this clear? Or multiply by 2 as well. Is this clear?
Yes, sir.
Yes, sir.
So which options over here are correct? Which diagram correctly represents the energy profile of this reaction? It's an endothermic reaction.
सर C और D में से लेकिन delta H का aromatic क्यों कर रहा है?
ये तो endothermic, these are exothermic actually.
Oh, okay. Yeah, A and B में वो aromatic क्यों कर रहा है?
Is it A?
Yeah. It's going
Is
to
it
be
A?
All
Okay.
arrows, they start from the reactants.
Okay.
Okay, so it's going to be A. I said this one, you've got the equation reaction this is the overall equation that's given. So which statement are correct? So you've got an oxidation equation, and you have a reduction equation. The first thing is when you have to make the complete redox reaction, you would have to multiply both equations by a certain number so that the number of electrons gained and lost, they become equal. And that number is, I have to balance the number of electrons lost and gained. I'm going to multiply this by 2, the whole equation. I'm going to multiply this by 3, the whole equation. And I'm going to just add the reactants and add the products. So the reactants are 2MnO4 minus 1, 4H2O. What are the other reactants at the bottom? That's 6OH minus 1. And there is 3SO3 minus 2. And then the products. MnO2, that's 2MnO2. And then I've got multiply this by 2, that's 8 OH ions. Then I have 3SO4 minus 2. Plus 3 H2Os. So did I balance this correctly? 3 SO4 minus 2, 3 H2Os, 8 OH ions, that's 2MnO2. Everything looks fine. The reactants over here, that's 3 SO3 minus 2, 6 OH minus 1's 4 H2. Everything is fine. Now some of these things will cancel out. So the OH ions will cancel out and you'll be left with 2 OH ions on this side. The water, I think that will also get cancelled out. So the 3 water molecules on this side. Over here, I'll be left with just 1 water molecule. So that's it. That's my equation. So U is 2. H2 is that's 1. W is 3. This is 2MnO2, and that one is 2 OH ions. And I've got 3SO4 minus 2, so that's 3. Anyway, so what's the correct options now?
Sir, I think all of them are correct, so it's A.
Sulfur is oxidized from +4 to +6. It is. Manganese is reduced to a state of +4. That's +4. This is +7. That's, and U, X and Z. U, X and Z, they are exactly the same. Everything is correct. Next one, is saying that there's H2O2 that decomposes to form water and oxygen, and Br-1 ions are catalyst. So Br-1, they react, they turn into Br2, and the Br2 then converts back into Br-1 in the second reaction. So what type of catalyst is this? Homogeneous or heterogeneous?
Homo?
Okay, that's homogeneous because it's the same state. All of them are aqueous. And step 1, what's happening in step 1? Reduced or oxidized?
Sure, they are oxidized.
Oxidized.
It is
Let's
oxidized.
see.
It's Br-1 turning into Br2, so losing electrons. So the answer is C. Next one, hydrogen and iodine react together to form, it's an exothermic reaction. It's a 1 meter cube reaction vessel. It contains H2, I2 and HI gases at equilibrium. The temperature is changed such that the total pressure in the 1 meter cube vessel doubles. What is the effect of the value of Kp and on the position of the equilibrium? So he says firstly, he says that it's an exothermic reaction in the forward direction, right? So it's an exothermic reaction. And then he says the temperature is changed. We don't know what's happening to the temperature. But he says that the total pressure in the 1 meter cube vessel doubles. So total pressure doubles.
So sir, अगर temperature ज़्यादा होगा तब ही pressure increase होगा ना?
Why? The temperature is changed.
Increased, sir, I think.
Hmm?
I think temperature increased because it says that it causes the pressure to increase.
So which side is the equilibrium shifting? Because remember, no matter what side it shifts, the pressure should not change. Because you got 2 moles of gas. And if it moves backwards, you still have 2 moles of gas. Right? So the pressure should not change because of the equilibrium position. So the point is that the equilibrium position, in this case, because you have equal moles of gas, they're all gases, right?
Yes, sir.
So that should result in no change in pressure, right?
Yes, sir.
So now you've got an issue. So that means we can't really predict where the equilibrium is shifting, because if it shifts to any side, the pressure should not change, right? Is that clear?
Yes, sir.
So why do you think the pressure is doubling?
Sir, no, I'm not saying it's doubling, but I'm saying that it increased because it says that pressure here in the vessel doubles. So maybe it's just like it was just like temporary and doesn't last.
No, it's not going to last. Even if it moves either way, it's not going to change.
Do
I
we
mean, the
consider the temperatures?
Now explain to me why the pressure doubles. Like the equilibrium has no role to play in that. Do you get that point, that the equilibrium position, no matter whether it shifts forward or backwards,
Oh,
the
is it the
equilibrium
rate step?
Yeah, it's because so the first thing is clear that the equilibrium position is not going to have any effect on the pressure. Whether it moves backwards, whether it moves forwards, it will play no role, right? Is that part clear?
Yes, sir.
Yes.
So why is the pressure doubling? The pressure is doubling because you're at a higher temperature. At a higher temperature, the molecules have more kinetic energy. So they would obviously exert more pressure. So that's why we can be pretty sure that he's increasing temperature.
Yes, sir.
Is that clear?
Yeah.
Yes, sir.
Yes, sir.
Abhinav, if we are at a higher temperature, so now we know that we are at a higher temperature. Now tell me which equilibrium will be favored, forward or backward?
Endothermic backward.
Backwards.
Because that means
We move to the left.
it will move to the left, right? And that would mean that the value of Kp will decrease. I mean, Kp is what? Products over reactants. You'll have more reactants and less products. So the effect on the position of the equilibrium is that it will move to the left and it decreases. So the answer will be
सर आपने बोले कि backward reaction होगा तो products increase होंगे.
नहीं, backward में तो कम होंगे products ना. Backward होगा, so there's going to be less HI, right? Because all of it is going to get converted into H2 and I2.
Okay. Yeah.
ठीक है, but is this clear? This one?
Yes, sir. Yes.
Sorry. I said next. So basically, pressure was increasing Equilibrium had nothing to do with it. So the only possible way it was increasing was that you were at a higher temperature. So that's how you figured out that the temperature was increasing. I said, now this next reaction, in this reaction, which compounds act as the Bronsted-Lowry acid? In reaction 1, who's the acid? And what's the definition of an acid? Is a proton donor, right?
Yes, sir.
So first reaction, who is the one that donates a proton?
Sir, is it the organic molecule?
No, that is accepting a proton. It had 5 hydrogens. Now it has 6 hydrogens. So this one is the base. And who gave it the protons? It's the water that gave it the protons. So that's your, because on the other side, you're left with an oxygen, right? The water is the one that gave the H to this thing. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
So in reaction number 1, it's water. What about reaction number 2? Who's the acid now?
Is it still water, sir?
It's still water because water turned into, I mean, all the water turned into OH ions. So that means water is the one that's losing H plus 1 ions. So it's still water. Right? So that's still water. That's the next one. Which statement about atoms and molecules is correct? So read this and tell me what the answer is. Is the first statement true that it's the simplest whole number ratio of atoms of each element in the compound?
Yes.
That's the
molecule-
empirical, sir.
And that's the empirical formula. Molecular formula is actually,
Oh, yeah.
it's a glucose, and that's the molecular formula. It tells you the actual number. So the first one is wrong. 1 mole of any substance contains 6 × 10⁻23 atoms.
So should I consider 6.02 here or 6 enough, sir?
Yeah, consider this as 6.02. 1 mole of any substance contains these many atoms. Is that true?
No, sir. I think it's particles, not atoms. Or
It's because if you have glucose, right? If you have 1 mole of these, like 6.02 times 10⁻23 molecules of glucose, right? The number of atoms is a lot more. Like every molecule has how many atoms? That's what, 24? So you would have to multiply it by 24. That means it's going to have 24 times the atoms, right? So you're not counting atoms when you have 1 mole of a substance. It could be 1 mole of anything. The number of atoms in those molecules will be a lot more. Is that clear?
yes, sir.
So this one is also incorrect. The relative atomic mass of an element is the ratio of the average mass of one atom of the element to the mass of an atom of carbon-12.
Sir, I believe it's D because like I'm not sure about the ratio.
Element is the ratio of, it is the ratio of average mass of one atom of the element to the mass of an atom of carbon-12. What's the next one? The relative formula mass of a compound is the sum of the individual atomic masses of all the atoms in the formula.
C seems better, sir.
The only issue I have with C is that it is true, but it's 1/12 the mass of a carbon-12. It is a comparison. So relative atomic mass of an element is the ratio of the average mass of one atom of the element. That's fine to the mass. So everything is fine except for the 1/12 part. That is the only thing I have an issue with. So D looks better. But where's the, just a second. This is question 14, right?
Yes.
The question 14 is D. They went with D. So I think the only issue over here is that it's 1/12. Okay, here's the where's the chemistry definition? I say it's 1/12 the mass of carbon-12. Anyways, forget this. As the next one, Boltzmann distribution. So you've got this. What happens? 1 mole of the same gas is added, and the gas remains at temperature T. So he adds 1 mole of a gas to this thing. There's 1 mole of gas, and what he does is that he adds 1 more mole of gas. What will happen to the distribution? I mean, the molecular distribution would remain the same, right?
Same, but the peak would increase.
So it's going to be A, right?
Yeah.
You'll just have the number of particles at every energy that's going to be higher, right? तो वो जो आगे पीछे move होती है ना, it's going to shift only if you increase or decrease temperature. For example, this is higher temperature, this is lower temperature. This one is incorrect anyways. Now the next part, in the reaction shown, the concentration of both X and Y are reduced to half of the original values whilst keeping the total volume of the solution constant. So he's reducing the concentration of X and Y. And simultaneously, the temperature is increased from 298 to 348. Which prediction is definitely true? So he reduces concentration. At the same time, he increases temperature. Did he say that the reaction speeds up or slows down? So one of them suggests, yeah, huh?
Did it just cancel out, sir?
They would cancel out because this one states that it's decreasing concentration, reduces reaction speed. The other one increases reaction speed. So not really sure what's going to happen in this. Which prediction? So we're not really sure whether it's going to completely cancel out or whether one of them has a greater effect or the other one has a greater effect. So we don't know whether it's going to speed up or whether it's going to slow down. So so which prediction is definitely 100% true? So a smaller proportion of collisions between particle X and particles Y will be successful. We can't tell. We can't say whether it's slowing down, we can't say whether it's speeding up. The average kinetic energy of particles X and particles Y will increase. Is that true?
So temperature affects Ke. So if temperature increases, Ke will also increase.
So this is 100% true because if you increase temperature, the energy of the particles will definitely increase. The reaction is slowing down. Why? Because you're diluting it. So they're far away, so they'll take a longer time to sort of meet each other and collide with each other. You'll have less frequent collisions, but at least the energy of the particles will definitely increase. Is that clear? So this is 100% true.
Sir, what about C? Because you said that it cancels out the conditions.
We can't really say that it 100% cancels out.
Okay.
Maybe the temperature has more effect. So we can't really tell whether it's going to cancel out completely or not. So that's not definitely true. Somewhat true, but not definitely true. The frequency.
Sir, you said that the kinetic energy is increasing, right? Because the temperature is increasing. So why are you so sure that temperature increase हो रहा है और concentration ज़्यादा reduce नहीं हो रही है? What if it's related to reduces? What if it's
concentration
related
तो
to
बात ही नहीं हुई
concentration?
मुझे खाली स्टेटमेंट है सिर्फ यहाँ तक करो
Uh-huh.
टेम्परेचर इंक्रीज करोगे the kinetic energy will increase. Is that true or not?
Yes, it is.
100% true. It's 100% true, right? Whenever you
Okay.
increase temperature, the kinetic energy will increase. So, I mean, only this statement that is true. That is 100% true,
Okay.
right? As the next part, a student investigated the chloride of a period 3 element. This is what the student wrote down as a record. So there's a chloride of period 3. It's a white crystalline solid, so it dissolves easily in water, giving a solution of pH 12. So a very basic solution, right? First thing, white crystalline solids. I've got Na, Mg, Al, Si. What comes after that? P, S, right? So all of them, Cl, argon, right? So whose chloride is a white crystalline solid?
This is the first four, sir. Till Si.
Not even Si. SiCl4 is a liquid. Remember that.
Oh,
the,
yes.
the first three. NaCl is definitely a white crystalline solid. MgCl2, that's a white crystalline solid. AlCl3, that's also a white crystalline solid. Silicon chloride is covalent. You've got lower melting and boiling points now. Aluminum chloride is also covalent. When placed heated in a rolling bun, the compound melted after several minutes. So it can't be AlCl3. AlCl3 is a covalent molecule. It dimerizes. It evaporates very quickly. So it's not going to melt after several minutes. It's just going to boil immediately, right? So remember, AlCl3 it forms a dimer and it vaporizes very quickly. It's a covalent molecule, weak van der Waals forces. Is that clear? So you're left with NaCl and MgCl2, these two. White crystalline solids that melt after several minutes. What happens when NaCl is added to water? What happens to it? And what happens when MgCl2 dissolves in water? Both of them, they
just hydrolysis, sir.
they just dissolve. MgCl2 as well, it mostly just dissolves. But with MgCl2, you have very little hydrolysis. Like some of the Mg ions will combine with the water OH ions and form magnesium hydroxide. And the water will have H+1 and Cl ions, so it will become very slightly acidic. So it will have a bit of a hydrolysis, but very little. So the first one has a pH of 7. The second one has a pH of around 6.5. So 7 and 6.5. The next part is it's now at least one of the recorded observations is incorrect. That's true because it can never be alkaline. It's either 7 or it's either, well, it's never actually alkaline. Aluminum chloride, it will also react with water. It will form aluminum hydroxide, strong hydrolysis, resulting in HCl being produced, right? Silicon does the same. If you react it, silicon chloride also reacts, forms silicon hydroxide, and will form HCl, right? The same happens with phosphorus chloride as well. PCl3 reacted, it forms phosphorus acid and HCl. So they're all acidic, all of them are acidic, except for NaCl. No one is alkaline. TK, is this clear?
Yes, sir. Sir?
Yeah.
For SO, how would you know that it was liquid? Because like, is it based like on previous knowledge or because like I've just seen the
SiCl4?
Yeah.
You have to remember that the SiCl4 is a liquid.
Sure, because like it's not there in the handwritten notes, so
it's there in the. I mean, you should use these ones as well. Just 1 second. I mean, there's one with detailed explanation. I'll share those as well. Just 1 second. There's I guess this one.
Yes, sir. Share it to the group, sir.
Okay, I'm sharing it over here. You can just 1 second. So here are your detailed ones. I mean, remember in inorganic, it's mostly like they don't go into detail. They're just, so the notes are good. Okay, but you have to know a bit of a knowledge about like metallic bonding and stuff like that, right? So these are like very detailed notes. They're harder to remember. But over here, for example, SSCL for this one, I've added that NaCl is a white solid. This is white solid. ElCl3 is white solid. This is a colorless liquid. PCl3 is a colorless liquid as well. PCl5 is an unstable white solid. Okay, so you've got to remember these. I'm sharing them on to the group as well. In the chat,
Okay,
I'm sharing the link in the chat.
Okay, sir. Thank you.
Okay, the Zoom chat. Okay, I've sent it over there.
Okay.
So next one is the elements in period C and the compound show trends across the period from sodium to chlorine. Which was correct? Electronegativity to the right increases or decreases?
So it increases.
And acid-base behavior. Do they become
So
acid?
it's from basic to acidic.
So let's see. Well, next part is the table shows melting points of SiO2 and P4O6. Now this one, SiO2, P4O6, remember, is a kind of a white compound. It's a simple molecule. SiO2 is a giant covalent structure. So what explains this? So it's basically giant molecular, and the other one is simple molecular. That's why you have different melting points. Is that clear?
Yes, sir.
So then you have these ones. Let's do some more questions. Equal masses of calcium carbonate, calcium nitrate, barium carbonate, barium nitrate are thermally decomposed. The volume of gas produced in each experiment is measured under the same condition. Which compound will produce the greatest volume of gas? First thing, will the nitrate produce more gas or will the carbonate produce more gas?
Sir, I believe it's nitrate.
Because nitrate will produce 2 moles of NO2 and it will produce half a mole of O2 as well. So it produces more gas. A carbonate just produces 1 mole of CO2. So forget carbonates. So you're left with calcium nitrate and calcium barium nitrate. And they're both thermally decomposed. So who's got an equal masses? So when the mass is the same, who's going to have more moles? Lesser MR or more MR?
If there are more moles, then it has to be less MR.
Yeah, it's inversely proportional to MR, right? So lesser, so it's going to be calcium nitrate. That's the answer. So first thing, nitrates produce more gases, and calcium nitrate is going to have a lower MR compared to barium nitrate. So it's going to have more moles. So it's going to produce more moles of gas as well, right? Is that clear?
Yes, sir.
Yes.
As the next part is which row gives correct comparisons between the solubilities of calcium hydroxide and barium hydroxide and the thermal stabilities of the carbonates, barium and calcium. So solubility, who's more soluble, calcium hydroxide or barium hydroxide?
Barium.
To get down the group, the solubility becomes more. Who's more stable down the group? Stability increases or decreases?
Increases.
Okay, so down the group must be written over here. Just a second. So stability down the group, it increases. Strontium carbonate and barium carbonate have a much higher decomposition temperature, so it increases. So this one is barium carbonate will have a higher, and this is lower. So D is the option. Now the next part. Which statement relating to the elements in group 17 and the compounds is correct? Bromine will reduce Ki to form iodine. Is that true? Br2 will it displace Ki?
Yes, sir. Well, Br is above I.
So Br is more reactive. The top ones are more reactive, right? So the first statement, is that true? It's true.
Does it reduce it though?
The problem with the first statement is it does not reduce, it actually oxidizes it. Iodine is -1, over here it's 0. So it's actually losing electrons. So it's getting oxidized, not getting reduced. So the reduced part is wrong. So that's why it's wrong. Iodide ions form a white precipitate with silver. What's the test for iodide ions?
Yellow precipitates.
Yellow precipitate. Bromide ions also form a cream precipitate. So that's also wrong. So you just left with the last one. That is chlorine reacts with hydrogen. The other ones are all incorrect, right? Bromide ions react to form a white. They don't form a white precipitate as well. So that's the only thing. HCl gas is going to be produced, which is going to give you D. Okay, there's one problem with this one, and that's HCl is not really colorless. It's actually white fumes. So the other ones are definitely incorrect. I did open the marking scheme just a second. 22. It is D. So I think white, he's just calling it colorless. Now, next part is an excess of chlorine was bubbled into NaOH. How many moles of sodium chloride would be produced in the reaction? Now, hot NaOH. Again, this is again inorganic chemistry, group 17. So what happens?
Disproportionation, is it?
It's this one. You have to remember this reaction, that if you react it with hot NaOH, it will produce NaCl, NaClO3, and H2O. So it's going to produce NaCl, NaClO3, and H2O, and you need to know how it's going to be balanced as well. 6 NaOH, 3 Cl2, and there's going to be 3 H2Os. Now, first thing, how many moles of NaOH do we have? That's 6 times 100 divided by 1000, so that's 0.6.
Yes, sir.
So the moles of NaCl will be 0.5, 6/5. And then you have कि you उसको MR से multiply कर लो, so that's you just asking for the moles. So the answer will be B. Is that clear?
Yes, sir.
Next one is the product of the contact process is Z. Which reaction or process leads to the formation of a gas that can neutralize an aqueous solution of Z? Contact process, what is Z, acidic or basic? Well, what is formed in the contact process?
H2SO4.
Okay, so the products are always acidic. You get SO2, then you turn the SO2 into SO3, and then you react the SO3 with H2SO4. You get, so basically it's all acidic, right? So all the products are acidic. It's an acidic gas, and the product is H2SO4. So the aqueous solution is basically H2SO4. So what you need is, what kind of gas will neutralize it? It's not going to be acidic. It's going to be a basic gas. Is that clear? कि आपका जो product है, that's acidic. It's an acidic solution. So the gas that will react with it is going to be a basic gas. So the answer is C. Ammonia is basic, right? Is that clear?
Yes, sir.
Yes, sir.
But this one, last one. When ammonia is dissolved in water, a concentration of ammonium ions is formed. Which was correct? Ammonium ion. How many electrons does an ammonium ion have? N has 7 electrons. H has 1 electron. That's times 4. And the whole thing, it has a +1 charge. So that means 1 electron is lost. So that means you got 10 electrons. The change of the bond angle. What's the bond angle in NH3? And what's the bond angle in NH4 +1?
Sir, is it D?
It increases. Over here, because of the lone pairs, the angle is 107. And over here in tetrahedral arrangement, the angle is 109.5. So it does increase. Okay, is this clear?
Yes, sir.
Yes, sir. Sir?
हाँ जी.
Sir, I believe, did we like do paper 3?
We can start doing some paper 3s as well.
No, sir, because like I'm not sure, but I think I saw like in the recording there was paper 3 recording.
Yeah, there are some paper 3 recordings as well.
How many did you do, sir?
I mean, that's very few. I mean, we can do more paper 3 practical questions. We can just go through them.
Okay, sir.
Okay then.
Thank you, sir. Assalamu alaikum.
Islam.
Thank you, sir. Hafiz.
Hafiz.
सर
हाँ जी.
आपने सुबह कोई एएस की क्लास भी लेनी है, सिर्फ A2 के लिए आप कह रहे थे सुबह लेंगे एक और?
नहीं, मैं दोनों के कह रहा हूँ.
तो आप डबल क्लास लिया करेंगे सुबह
हाँ,
भी
हाँ.
और ओके टाइमिंग क्या होगी सुबह की क्लास की एएस की?
वो मैं बता देता हूँ, ठीक है, मैसेज कर देता हूँ उसमें ग्रुप्स में.
ओके सर, A2 और एएस की दोनों की कर देना आप ग्रुप में मेरे.
चलो ठीक है.
थैंक यू, अल्लाह हाफिज़.
ओके.